Alrighty, today we're going to move on to section 1.5, simplifying expressions that have exponents. So simplifying, we'll have a couple properties to go through, and then we're going to hit some scientific notation here, because that's really the same as just adding exponents or scientific notation. And as you take in chemistry, most of you probably are, you're going to need the scientific notation take pretty strongly. So what are we talking about here? We're talking about if we have x squared times x to the fifth. We have exponents. What do we do to those? We're going to add those. So we add exponents. Now, if we have numbers involved, we could have 5x squared, and we'll put a bracket around that, times 3x to the seventh. Now we have that. We multiply the numbers, which would be 15, and add your exponents. So this is really algebra 1, if you remember, working with exponents, okay? Multiply numbers, add exponents. So if you're writing something down, if you haven't written anything down, you want to write that down. Multiply numbers, add the exponents. Multiply numbers, add the exponents. And that's what's confusing, because we're doing two operations there. One thing we're multiplying, the other we're adding. So that's a skill that we're going to need. We're going to do another skill called expansion, where we expand out the equation, or what it looks like, to what that x or what that power might be working on. So that's where we're headed. So multiply the numbers, add the exponents. So this is what we're talking about. If we had a to some power, we're going to expand that out. I want to show you what expansion looks like. This is really a good little chart to help you think about this, okay? You really need to know what the power is acting on. So this is exponential form, okay? Now, that power 3 is only acting on x. So if we do expanded form, that x is going to have to be 3 times, isn't it? My second one, so this is my first example. My second example, that power of 3 is acting on 2x. So notice, so that negative out front, but 1, 2, 3 of those. My third example here is that power of 3 is acting on both the negative, the 2, and the x. So the expansion would be how many of those? 1, 2, and 3. So once we expand, we can go to what my original statement with you this morning was what? Multiply the numbers and add the exponents. So if you get stuck anytime with an exponential problem, you can always multiply the numbers and add the exponents. And that's expand it, and multiply the numbers and add the exponents. All three of these would be different answers, of course. It's kind of unique. Well, no, they're not quite, but close. This one's just going to be negative 2x to the third, just what it started with. Here we're going to have negative, but we have 2 times 2 times 2, which would be 8 x to the third if we were simplifying, but that negative's still out there. Now we have negative times negative times negative, still going to give us negative 8 x to the third. So those two ended up being the same, and that's just by coincidence, not by a mathematical pattern or a mathematical rule. Note takers good there, everybody's okay? So what the power is acting on is called the base, and that's important as what we got going on there. Let's see what we can do. Expand. I'll do this first one for you, and then you can write out the next. So that power of 2 is only acting on the 5z. So this isn't simplify, it's just called expand. So it's going to be 5z times 5z. And that's all there is to that. So the next one, it's only acting on the what? The s. So we still have that negative, but then we have s, 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 and s. Does that make sense where the 4 is only acting on the s there, isn't it? So you can give me a second for that last one there. You can expand. This isn't simplifying, this is called expand. This is easy little thing you can do and make a couple points on the assessment when we have it. Expand. So is there anything extra acting on that 3? No. How many h's are we going to end up with? 3. And then this set, k plus 3, is going to be twice. Remember, what is this called? Expanding. You're not simplifying, you're expanding. Skill 1 this morning, how do we feel? So whatever that power is acting on, make sure you see whatever the base is, that's how many times we're going to need that particular one. Now, if we were simplifying, that goes back to multiply the numbers and add the exponents. Everybody good? Let's move on. We have a couple of properties, and some of them you might want to jot down, others you might not. It's okay. Anything raised to the 0 is 1. You know, I could have 5 to the 0 power, it's still 1. Any x to the 0 is 1, so that is the 0 exponent. The negative one is a little bit more tricky. If we have a negative exponent, if you remember from algebra 1, okay, we can rewrite that. 7 to the negative second, we can rewrite that as 1 over 7 squared. We can move these exponents from numerator to denominator, changing their sign. Now, the number doesn't change, just the sign of the exponent. Also, if we have a fraction raised to a negative exponent, a fraction here raised to a negative, we can flip that fraction, and now our exponent becomes a positive value. That's kind of nice and very helpful. So negative exponents, we can move. For example, if we had 4 to the negative second, it's really equal to 1 over 4 to the second, or in fact, 1 over 16. Now I want you to write one more thing down, another rule that would help you. When we say simplify, when the directions say simplify, that means no negative exponents. So when we say simplify, we want no negative exponents. So if I had something like this, x to the negative second, y to the negative third, we'll put a 5 out front, and I said simplify this, okay? The answer would be 5 still okay, it doesn't change. But to make that a positive exponent, I'm bringing it down here. Make that a positive exponent, I'm bringing it here. So that would be simplified. We can really get crazy if we put something around this and put -2 with it. We'll do some of those here in a second, but things can get a little bit hairy then, okay? But for now, does that make sense to you right there? Is everybody okay? All right. So what are my directions? What do the directions say? Simplify. So that means what? No negative exponents. See what you can do here. A little bit of guided practice. One of my favorite things to do. You try them and then I'll see. You will see when I do them. So to write this as positive, it's gonna be 1/3 to the second, right? That would make it a positive, but then we know that ends up being what? 1/9. The next one is a fraction to a -2. How can I make that a positive exponent? All I'm gonna do is what? Flip the fraction. Now, there is a quotient property that allows us to go one step further and write this as quotient, because that's division, fraction, 3/2, 2/2, kind of like distribute there. Does that make sense? So now we end up with 9/4. So that is a property that I'm going to show you here in a second, but there's a good example of it right there. All right, we got another fraction. We're going to be able to write that as 3/1 to the positive second, aren't we? So in fact, if I have any number to a negative, I can flip it and put it over 1. If I had the number 3 to the negative, be 1/3 to the positive. You can do it that way too. So there's lots of options here. Now this guy ends up being 3 to the second over 1 to the second. 3 to the second, 9. 1 to the second is 1. So this simplifies to just 9. About as exciting as the rain we had all yesterday afternoon, isn't it? Last official day of summer, and we're all stuck inside, aren't we? Yeah. I had my whole family over. There's 11 grandkids, we have a swimming pool, and they were all in it, and I was in it with them, and we heard some thunder. It wasn't a very great day to swim though, it was kind of chilly, but I put the heater on, it was 88 degrees, so, and when you're 10 years old, you don't care about that kind of thing, you're jumping in the pool, right? So they were very disappointed when I told them we had to get out, but it turned out okay, no one got too upset. All right, some rules here, honest folks, I wouldn't write it down, okay? Unless you feel like one of them that you might need. First of all, product is what we just taught. Add, multiply the numbers, add the exponents, okay? So x to the third times x to the seventh is x to the 10th, okay? Quotient, what I just showed you. We can mix those up, we can change, we can bring exponents up by moving them from the bottom to the top, okay? Sometimes the quotient, some students like to think of it as this way. We have x to the 4th here, and we have x to the 2nd here. Sometimes think of it as you can expand and cancel. How many do I have up top? 4. How many do I have underneath? 2. So they just kind of cancel, and they end up with x squared, right? The other option is I could bring this up and write this as x to the 4th minus 2, because then that just comes up minus 2, and that gives you the same answer as x squared. So those are okay either way, all right? Jim, all right, John, you look extremely bored out of your skull.
I'm tired.
Tired?
Yeah.
Tired from what? The next one, the power of product, is kind of like distributive, okay? Remember, here we are raising to the power property, and that can get a little confusing. So if we have x squared raised to the 3rd, If we were to expand that, that'd be 3 of those, wouldn't it? X squared, X squared, X squared, so really this ends up, you multiply those, it's a simple way of simplifying it. 2 times 3 is 6, there, x to the 6. This is kind of like distribution or distributive property. You move those around there a little bit. And I just showed you this one already. The quotient, we have 3 to the 5th raised to the 2nd. We can rewrite those as 3 to the 2nd over 5 to the 2nd. Some properties of exponents there. How we feel? Let's put a couple of these in place, see if you can practice a couple. We're almost done. Let's just practice now. We're done with writing stuff out. Again, what are the directions here? Simplify. That means what? No negative exponents and simplify the number. Now, be careful. There's a -4 there, but not a negative exponent. They're different. So this first one is right simply, the very first thing I said this morning was multiply the numbers and add the exponents. So this guy ends up being what? -12, how many z's? 9. Now the next one's a little harder. You got some simplifying, you got to raise to the power, and then you also have the same value, you have the same numbers on top, or excuse me, you have the same variable on top as you do on the bottom, so we're going to need to simplify those z's. See what you can do there. And Joan could use a few more z's. So we're raising to the power. This is going to be y to the 3rd, z to the 9th, because that really means 3 of those over z to the 5 times 3 is 15. Did we understand raise to the power there? You could expand that, and then you would just add the exponents. That can work too. Now, we're not quite done yet because we have z's on top and z's on bottom, right? You can think of it a couple different ways. You can cancel. We have 9 on top, 15 on the bottom. We're going to end up with what? Y to the 3rd, and how many underneath? 6, isn't it? I'm going to show you another way also, but does everybody see what I'm talking about there? We have 9 on top, we have 15 underneath. We're just going to cancel 9 on the top and cancel 9 on the bottom of it. Okay. Now, the other way you could write this is y to the 3rd, z to the 9th, and z to the -15th. I could bring that up, you see? I'm just showing you another way in case for later use. So now we end up with what? Y to the 3rd, z to the -6, you still there? Okay, makes sense? And then we'll take that -6 down, and that's how we come up with that same answer right there. So there's a couple different ways you go about it, whatever feels comfortable to you, whenever you feel good about it. Try that last one, 5x to the 6th raised to the 3rd, so. I'll give you this answer, and then I'll show you how we get it. 125x to the 18th. So the first question is, where do you get that 125? Well, that's what? 5 to the 3rd power, isn't it? 5 times 5 times 5. And then x to the 6th raised to the 3rd is 18. If you don't see that, you can always do the expansion. Expansion would be 5x to the 6 times 5x to the 6 times 5. You see, that is it. That is it expanded, right? that thing 3 times. And then you multiply the numbers and add the exponents. So every year students get a little tricked up with the power rule, so be careful there with that. See if you can simplify. What does simplify mean? No negative exponents. So do we have a couple here? So it's not the negative numbers, but the negative exponents. So that -3 is acting on this, isn't it? So I'm just gonna write it as 1 over . I want you to notice a couple things here. Did the 2 still stay negative?
Yes.
It did. Did I change any of the exponents to the third? Did I change that? No. The only thing that changed was my -3. Now I'm still not done. I need to do this part. So I'm still gonna have 1 on top. What's my number gonna be down there? Anyone? Any brave souls? What's gonna be the number? Right, Joe, -8. Thank you. What's gonna be my A? A2, how many A's am I gonna have? I'm gonna have A to the 9. And B, how many B's am I gonna have? 3. Boom. That's my point here. The only thing that changes is the exponent. Don't change the numbers. Don't make the other exponents go negative when you take them down. Is everybody good there? See what you can do with the last one there. Should be able to handle that now that I showed you that one. This is a lot of fun, isn't it?
Yeah.
This is better than, Labor Day weekend, grilling out cheeseburgers and hot dogs. We got brisket from Old Carolina Barbecue, it was pretty solid. Yeah, had some in my lunch today too. So to write this as a positive negative exponent, we're gonna make it 1 over, we still have our parenthesis, we're gonna have 6a to the 4, the b to the first. That's to the power of 2 now, isn't it? Positive 2. Remember, simplify, get rid of negative exponents. We're raising to the power, so it's gonna be 1. What's my number gonna be? 36. How many A's? 8. Had a banana this morning for breakfast. How many B's? 2. Simplify means no negative exponents. Multiply numbers, add the exponents. Unless you raise to the power. If you raise to the power, then you're gonna multiply them. Still okay, everyone? All right, scientific notation, last thing today. Remember, this is what type of number? Is it small or big? This is big. What's this one? Small, okay? All right, we're gonna do the same thing here. We're gonna add exponents. Let's try 1. So I can rewrite this as 4.5 divided by 1.3 times 10. Well, I have -5 there. If I bring this up, it's gonna become also -6, right? Exponent. This should be 5. So you see why this part is part of this section. Now, 4.5 divided by 1.5 gives me what? 3.0 times 10, I'm just gonna add my exponent, 10 to the what? Negative 11. See if this makes logical sense to us. Is this a very small number? Yeah, it's a really small number, isn't it? What's this guy right here? He is small, isn't he? This is a bigger number, isn't it? If I have a small number on top divided by a bigger number on the bottom, I'm going to get even a smaller number, aren't I? Does that make sense? Is that even a smaller number? Yes, it is. Now, your calculator does have exponential mode. You can use it if you want to do it through exponential on there. Again, your chemistry, you're going to need this for some chemistry stuff. So it's a good skill to practice that. We did this one manually, but you can do it that way also. We're multiplying here. Am I going to get a very large number or a very small number? It's very small times very small. So 4 times 3.1, you can throw that in your calculator. This is pretty easy. 4, anybody? Okay, 12.4 times 10, what do? We multiply the numbers and add the exponents. So it's going to be 10 to the negative 10. Now, there is one problem with scientific notation. We want it to always be 1.24. So we always need to move this decimal. So we're moving that decimal over 1, so it's going to be times 10. We moved it 1 over, so it's negative 11. That's it for today. How does everybody feel about that? Okay?